Since the 1960s, space exploration has been regarded as vital to the progress of the human race. Humans dream of one day being able to live in space, which is gradually becoming closer to the realm of possibility due to advancing technology and more missions planned for the future that will allow humans to explore space further and faster than ever before. Green propellant is one such example of advancing technology that has wide-reaching implications for future space travel. For years, various spacecraft have used hydrazine to provide power for their thrusters. Hydrazine works as fuel by being mixed with dinitrogen tetroxide, producing an instantly burning mixture. As the mixture burns, hydrazine decomposes into hydrogen, nitrogen, and ammonia gases. This is an exothermic reaction, meaning the decomposition of the hydrazine mixture produces energy that powers the spacecraft, just like the wood on a match burns to fuel the fire and produce heat energy. Hydrazine is commonly used as fuel for spacecraft since it is easier to store as a liquid at room temperature. Unfortunately, hydrazine is a highly toxic and easily combustible fuel, making it very dangerous for humans. While handling and transporting this fuel, scientists have found accidental contamination of hydrazine in the environment. Although it has not caused significant harm so far, as more vehicles are launched into space in the future, this contamination could pose a threat to wildlife and human health. This is where the Green Propellant Infusion mission comes in. NASA, along with the help of other aerospace companies, created the GPIM, a project that develops and tests the use of a new fuel. This fuel blends hydroxyl ammonium nitrate and an oxidizer, creating a new form of hydrazine fuel called AFM315E. Green propellant is more stable than hydrazine, and instead of creating harmful gases when burned, the new propellant only releases non-toxic gases, including water vapor and carbon dioxide. Green propellant has a higher density than hydrazine, allowing more fuel to be stored in the same amount of volume. Green propellant also provides more thrust with the same amount of fuel. Another way green propellant will be able to increase efficiency when launching vehicles and spacecraft is how fuels are handled. Workers handling hydrazine are required to wear hazmat suits for their protection, which costs precious time. In comparison, those who handle green propellant only need to wear basic safety gear, rubber gloves, lab coats, and splash visors. This minimizes the processing time that needs to be allotted to prepare the spacecraft for launch, condensing weeks into days. In 2013, Ball Aerospace and NASA successfully tested the green propellant, which achieved an 11-hour continuous burn versus the quickly burning hydrazine, just like a candle lasts longer than a match. The Green Propellant Infusion mission will be launched on the SpaceX Falcon Heavy rocket on June 24th this year to test the application of green propellant. Specifically, the GPIM spacecraft must be able to stop whenever controllers cause it to tumble. With the new propellant, the spacecraft's thrusters must point in the correct direction at all times and should be able to operate with an idle or almost empty tank. If the green propellant succeeds in fulfilling these requirements, it will likely be implemented for upcoming missions, promising a less toxic and more efficient future of space travel. As humanity becomes increasingly aware of our impact on the Earth, we must work towards minimizing our footprint while continuing to strive toward scientific and technological progress. Green propellant has the potential to be a safer, less expensive, and sustainable rocket fuel, allowing us to fulfill our mission of launching further into deep reaches of space.